Today, we are going to finish up section 2.6 and then hopefully get through 7, 8, and 9. 2.7, 2.8, 2.9. So, writing a linear function. When we have some information and it asks us to write a function, we can use a few different formulas. It's up to you which one you are more comfortable with. One of the things that we talked about last week, or last class, when we have g of 1 equals 4, that means that's the ordered pair 1, 4. So again, this is the ordered pair 1, 4. Over here, g of -3 equals -2 means that this is the point -3, -2. When we have 2 points, the first thing we have to do is find the slope. Can you just pull that door shut a little bit behind you? Thank you. So to find a slope between 2 points, y2 minus y1 over x2 minus x1. So, -2 minus 4 over -3 minus 1. This gives us -6 over -4. And when we simplify, that's 3 over 2. Again, our slope is 3 over 2. Now that we have a slope and some points, we can actually plug into point slope. I'm going to show you 2 different ways that you can plug into an equation. Option 1. Y minus y1 equals m times x minus x1. This is point slope. Which point would you like to use? 1, 4 or -3, -2? It doesn't matter. Okay. I also would have gone with 1, 4, so we don't have to deal with negatives. So y minus our y value is equal to the slope we just found times x minus our x value. We can rearrange this by distributing the 3 halves first. And then we'd have to add 4 to both sides. So this would give y equals 3 halves x. 4 is the same thing as 8 divided by 2. So -3 over 2 plus 8 over 2 gives us 5 over 2, or you could have just converted that to a decimal.
Which unit are we on?
2.6. A second option. You could have gone straight into y equals mx plus b. A little bit. But we don't know what b is, but we know that our slope is 3 over 2. And we use the point 1 comma 4. So if we solve for b, 4 equals 3/2 plus b. Subtract 3/2 from both sides. Five halves is b. So we would still get y equals 3/2
Hunter
x
Thunder to the office, please. Hunter Thunder to
plus
the
5/2. So it's up to you which option you'd rather use. Does not matter. But as you see, you'll get the same answer either way. Okay? So if you're given 2 points, find your slope first, then use your slope and one of those points to write an equation. So this is the part that we had skipped during the last class. All right. Other parts that we skipped from last class, I believe, were piecewise functions. Let's see. We talked a little bit about piecewise functions. The inequality tells you when to use the function on the left. It's based on certain values of x. So if we're sketching a graph of a piecewise function, when x is less than 1, this is what we're using. It doesn't matter what the y value is. If x is less than 1, that is the function that we're using. If x is greater than or equal to 1, we're using that function on below. Does that make sense? Okay, so I'm going to show you using a table of values. I'm going to do it in 2 different colors. So for x is less than 1, I'm actually going to plug in 1, but this is going to be an open circle because it cannot equal 1, but it could be everything up to that point. So when we plug in 1, negative 2 times 1 is negative 2, plus 1 is negative 1. And this is where we're using negative 2x plus 1. If I plug in 0, we get 1. If we plug in negative 1, we get 3. Negative 2, we get 5. This is section 2.6. Negative 3, we get 7. Negative 4, we get 9. So let's go ahead and put those on our graph. 1, negative 1, again, is an open circle. So I put an open circle on my graph. at that spot. Then we have 0, 1, -1, 3, and so on. And we are going to connect those with a nice straight line, because this is a linear function. Are we okay with that part so far? Do you understand where we're getting those numbers from? Either the ones on the left or the right. Okay, the left ones you're getting because those are values that are less than 1. The right ones we're just plugging in for x and solving. Okay? So, in red, we have 3x plus 1, and we're starting at 1. This is a closed circle because x is greater than or equal to 1. So this is 1, 4, 2, 7, 3, 10. So 1, 4, 2, 7, 3, 10. And we will connect those with a nice straight line. That is what that graph looks like. Okay? Questions on how to graph a piecewise function? Bless you. Okay, anybody need that up a little bit longer? All right. Okay, we talked about the basic parent functions. Now let's talk about transformations of those functions. When we have a function and something is added or subtracted to the outside of that function, meaning not under a square root, not in absolute values, not in the parentheses, it's telling you it's moving it up or down. It's taking that exact image and moving it up or down from what it previously was. So I'm going to use different colors to show you how these changes are happening. I'm going to start with f of x in black. The absolute value function starts at 0, 0 and goes up 1 over 1 in both directions to make a v. So this is our parent function. That's f of x. G of x, I'm going to do in blue. This is saying take that same function, but move it up 2. So every single one of those points is going to be moved up 2. And then do the same thing. Nothing else changed. This blue one was g of x. This is a vertical shift up 2. What do you think this h of x is going to be? So if g of x was up 2,
Down
Exactly. H of x moves down 3. So we take every point from the black one and move it down 3. And connect them. And again, that one is h of x. Questions? Okay. Let's talk about a different type of transformation. What if it's inside the function? So that could be under a radical. That's like the square root stuff. In parentheses, inside the absolute value. When something is being added or subtracted inside, it's moving left or right. Now what's interesting is it's the opposite of what's there. Okay, so f of x is our parent function. That is x squared. That also starts at 0, 0. But we have 1, 1, 2, 4, 3, 9. Negative 1, 1. Negative 2, 4. And negative 3, 9. Okay, that is a parabola. G of x, what would I have to plug in for x to make that parenthesis, what's in parentheses, equal 0? 2. This means it moves right 2 because I'd have to plug in a 2 to make that go to 0. So instead of being 0, 0, we have 2, 0. 3, 1, and negative 3, 3, 1, and 1. Yeah, what do I need to repeat?
I just gotta put the dots in.
Okay. So again, we had 0, 0, 1, 1, 2, 4, 3, 9. Negative 1, 1, negative 2, 4, and negative 3, 9. For this one, we're taking every one of those points and moving them right 2. Thank you. Thank you. So what do you think h of x is doing? Yep, left 3. So take the black dots and move everything left 3. Questions on those transformations? So we worked on vertical and horizontal shifts, meaning left, right, up, down. What if we combine them together? Let's first describe those transformations. If this is outside of that radical, okay, it's not underneath, it's not with the x, is this moving it left, right, up, or down? Down 3. Okay, what about it being on the inside, meaning under that radical? What does that plus 2 do? It's going to go left 2 because you have to plug in a negative 2 to make that square root a 0. This is actually left 2. So if we look at our regular square root function, 0, 0, 1, 1, 4, 2, 9, 3. We are taking every single one of those points, moving them left 2, down 3. 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 That is the transformation of that graph. This one is f of x equals the square root of x. That is called a parent function because it doesn't have any transformations on it.
Levi Takedash to the office, please. Levi Takedash to the office.
Okay. When there's a negative outside of a function, it reflects over your x-axis. That means it flips this way. It's like taking that x-axis and rotating it. But reflecting around your y-axis is when there's a negative in front of the x inside of a function, and we're rotating it around that vertical axis. So let's describe each of the transformations. There's 1 transformation, 2 transformations, 3 transformations. What is happening with the first one? When it's in front and not inside. Which one of those on this screen has a negative in front and not inside parentheses? That reflects over the x-axis. This means instead of being a function that looks like this, this flips it down. That reflects it down over your x-axis. The -2 is inside those parentheses. So what does that do? When it's inside the absolute value or parentheses, this actually changes your x value. This is a horizontal shift right 2. And this +3, any idea what that is? Yep, vertical shift up 3. Okay. So y equals the absolute value of x minus 2 is what we're starting with. This means if you wanted to, you could plug it into a calculator and graph it just based on the points. But this is an absolute value function, which means it's the v, but moved right 2.
Can you explain that again?
Yep. This is an absolute value function. This tells you it moved, whoops, right 2. Now, reflecting it over the x-axis means we're going to flip it down this way. So, whatever point was on the x-axis is going to stay there. This point was 1 away from your x-axis here. So this point was 1 away that way. So it's going to be 1 away down below. Same thing on the left. This next point was 2 away from your x-axis. So now it's going to be 2 away below your x-axis. Same thing on the other side. This next point, 3 away from your x-axis, so 3 away below. And you're going to continue that pattern for every point. So this is what our graph looks like. The red one is reflected over the x-axis. Okay. Stretching or compressing. It all comes down to the number that is outside and in front of that function. It is a stretch, bless you, when a is greater than 1. If it's a number between 0 and 1, it is a compression, also known as a shrink. Let me show you what I mean by that. Hopefully at this point you know that the absolute value starts at 0, 0 and looks like a V.
Levi Kakatosh to the office, please. Levi Kakatosh to the office.
So again, this is f of x. G of x means multiply the y value by 2. This is a vertical stretch because it's saying multiply the y value by 2. So here we still have 0, 0, but instead of 1, 1, we have 1, 2. And negative 1, 2. And instead of 2, 2, we have 2, 4. And negative 2, 4. Three, 6, and negative 3, 6. 4, 8, and negative 4, 8. And 5, 10, and negative 5, 10. So that's g of x. H of x is a vertical shrink. So I'm going to zoom in here. 0, 0, 0, 0 is still at 0, 0. But each of these values are half of its original height. I'm only doing the ones that are nice integers, so I don't have to go halfway through. But this original height here was 2. I cut it in half and made it 1. This height here was 4. I cut that in half and made it 2. This height here was 6. Cut it in half, and so on. So this is a vertical shrink. So that is h of x. Questions on those?
Tyler Panas to the office, please.
Okay.
Tyler Panas to the office.
Horizontally, we won't work with as much, but it's when there's a number inside. When it is inside with X, it is the opposite of what you would normally do. So values between 0 and 1 are actually a horizontal stretch. So a shrink would be when that value is greater than 1, when it's inside that function. So zooming in here, f of 1/2 of x. Because it is inside with x, this means it is a horizontal stretch. Because what would I have to do to x to make that 1/2 go away? How do I get rid of that 1/2? Multiply by 2. So this is essentially multiplying your x values by 2. So let's look at the points that are given. We have -2, 1, or excuse me, -2, -1. We want to multiply our x values by 2. So that would be -4, -1. Zero, 0, even if I multiply that x value by 2, it's still 0. 1, 3 would turn into 2, 3. And 2, 0 would become 4, 0. Does everybody see how that becomes a horizontal stretch? It's taking that exact image, centered at 0, and stretching it kind of like silly putty or the Stretch Armstrong thing this way. But leaving it at its center and just stretching left and right at equal intervals. It's making it double that distance from that middle line. Okay? So it doesn't matter what image is graphed there, you can do the same thing each time. So f of 2x, this is a horizontal shrink. This is saying you're cutting your distance in half. To get just a regular x, you have to divide x by 2. And I'm actually going to change that to a different color so you can see. Divide x by 2. So instead of being -2, -1, it's now -1, -1. 0, 0 stays the same. Instead of 1, 3, it's 1/2, 3. And instead of 2, 0, It's 1, 0. So when we connect these, it's squished. So what you'll see here, it's squished. This transformation in here, there's actually two. This flips over your y-axis. Meaning the single lady way. So it's flipping this way. And this is a horizontal shrink. So basically what we're doing is multiplying, or sorry, let me rephrase that. We are dividing our x values by -2. Divide x by -2. So instead of being -2, -1, it's 1, -1. Yeah? We okay with that? Instead of being 0, 0, hey look, it's still 0, 0. Instead of being 1, 3, it's now -1/2, comma 3. And instead of being 2, 0, it is -1, 0. So this thing looks like this. And I'm going to highlight because this looks so messy with all of these colors everywhere. So essentially what it looks like here is like that. Like
Levi
this.
Kakatosh to the office, please.
And like that. If that helps a little bit show those changes. All right. Instead of sketching, because you're able to use a calculator to plug in and graph and simplify, we're just going to describe the transformations. We're going to work from the inside out. So here, what does that -1 do? Because it's inside, almost horizontal shift, this will be right 1. Anything inside does the opposite of what you think it would do. Okay? Think about this in terms of x's and y's. Your x. Right now, your x is your x for a reason. You want somebody the opposite of your x. So when it's inside with the x, you want to do the opposite of what's there. The y doesn't really matter. It can change each time. That's fine. You don't have to do the opposite of that. All right, next. This 2 is outside of those parentheses. That tells me it's going to be a vertical stretch. It's outside of there. That's a vertical stretch. This negative is a reflection, but where does it reflect? It's with your y value. So if you're going from a positive to a negative y, that's reflecting over your x-axis. And the last one, yeah, let's do a green, I guess. The last one is a horizontal shift up 3. What shape is this? Because it's something squared. Your parent is y equals x squared. Any idea what shape that is?
Wait, can you say that again?
Yep, what shape is the x squared?
Triangle.
That's a parabola. It's a U-shaped, but it's not straight. It's curved. Okay? So again, when doing transformations, work from the inside out. All right. 2-8, combining functions and composite functions. I'm going to skip the definitions piece. I've got f of x and g of x. There's 2 functions here. If I want to do f of x, or f minus g of 4, this means take the function f, plug in 4, and subtract g and plug in 4. So, if I do that, this is f minus g. So when I do this, I have, and I'm going to use highlighters so it might be a little easier to see. I have stuff squared minus 6 times stuff plus 8. And then in G, I have stuff minus 2. Are we okay with that step? I just replaced the x's with highlights. In this next step, all I'm doing is replacing that highlighted piece with a 4, but you must use parentheses. So f of 4 is 4 squared minus 6 times 4 plus 8. Four squared is 16. 16 minus 24 is negative 8. Negative 8 plus 8 is 0. And then we're subtracting 4 minus 2, which is 2. Hey, look, our answer is negative 2. F divided by g of 3. This is letter B. This just means take your function f, and we're going to divide it by the function g. So I'm going to try to do this in one step. So we've got stuff squared minus 6 times stuff plus 8, and g is stuff minus 2. But we're plugging in a 3 into those spots. I'm going to zoom in here so you can kind of see it a little bit better. We plugged in a 3 into those spots where x was. This is equal to 9 minus 18 is negative 9, plus 8 is negative 1. 3 minus 2 is 1, so our answer here is negative 1. What do you think we're going to do for f plus g? This part means keep x. The only difference, now we're adding the function f plus the function g. F was x squared minus 6x plus 8. G was x minus 2. All you're doing is combining like terms. There were no other x squared, so it's just x squared. A negative 6x and x makes a negative 5x, and 8 minus 2 is 6. So the add, subtract, multiply, divide stuff isn't super complicated. You're just doing that with those functions. We've done a little bit of that already. So f minus g, I'm assuming yours does not have them on top of one another, right? You guys have them in 3 actual columns? Okay. So I think yours has fg of x, and that's E, and then yours has f, is, come on, Jen, f divided by g of x. All right, take the function f, x squared minus 6x plus 8, and we're subtracting the function g, which is x minus 2. The only difference we need to distribute that negative to the pieces that come after. X squared minus 6x plus 8,
Wait, how did you get that?
because it says f minus g.
Okay, wait, where did those -6 and the 8 come from? Or,
From the
Oh,
same
from the-
same function as
okay,
above.
Okay.
I was like, what?
Yeah, sorry.
No, you're fine. So this is now a negative x and a positive 2. Because when you're subtracting, you're changing the signs to everything after. And now we combine like terms. X squared minus 7x plus 10. Excuse me. When f and g are directly next to one
How many
another,
out to the office, please?
it just
How
means to
many
multiply.
out to the office?
This means we're doing x squared minus 6x plus 8 and multiplying that by x minus 2. Because of time purposes, I'm just going to put actually multiply them. You can use the box method or whatever method you prefer. So this would be a final answer of x to the third minus 8x squared.
I'm sorry, on the top,
Yep,
is that a 3 on top of it?
it's a 2.
Okay.
And then you'd get your final answer. Once you combine like terms and distribute. Again, just because of time purposes, I'm not going to show that step. And then f divided by g, x squared minus 6x plus 8 over x minus 2. If we could factor, I'm not as concerned with that though. Okay? I just need to know that you know how to set it up. Okay. Domains we've already gone through. So I'm going to put another asterisk here. We did that last class. Does anybody remember the 2 things we look for? Denominators. Remember, denominators cannot equal 0. And the second thing is square roots. Because the stuff under the square root cannot, or it has to be greater than or equal to 0. Okay. If it doesn't have fractions with x's in the denominator and it doesn't have square roots, your domain is going to be all real numbers or go from negative to positive infinity, which is the same thing. Okay? All right. Composition of functions. It's like function inception. You're putting a function in another function. This open piece here, you see how it's like an open circle? This means a composition. This means take the function f and plug g into the function f. So you're going to start with f, then plug in the function g. Okay, so let's try that. We are going to start with the function f. But instead of an x, I'm going to put that highlight again. So we've got x to the third. That is the function f. Are we okay with that so far? Then we have the function f to the third, but what's going inside is the function g into each of those highlighted pieces. And then, for some reason, I chose to plug in 1. Which means I've got that stuff plus 1 to the third power. Okay. Isn't that River?
Yeah.
Okay. And instead of x, we are plugging in 1. So when we simplify, 1 plus 1 is 2. 2 to the third is 8. Excuse me. All right, let's try it again. That's it for that letter A. Letter B means we start with G, which is x plus 1. Then we take that G and plug in F into it. So in this spot, we have x to the third. That's getting plugged in that spot. And then instead of x, we're plugging in 1.
Boyd, please return to class. Deanna Boyd, please return to class. Darwin Fish to the office, please.
1 to the third is 1 plus 1 is 2. Are the steps making sense when you break it down piece by piece? Okay. Do you want to try letter C, or should we move on to the next one because there's a whole bunch of them just with X that we can try? Do you want to skip down to the next section? Okay. So we've got different functions now. So f composed with g of x. What are we starting with? Start with f. So we've got 2 stuff plus 1. What are we putting inside that highlighted piece? What are we putting in place of that highlighting? x squared minus 3. And then we just want to simplify. So this is 2x squared minus 6 plus 1, which is 2x squared minus 5. We okay with that? Letter B, what are we starting with? Start with G. So we have stuff squared minus 3. What are we plugging in to that stuff squared? Oops. 2x plus 1 goes in that spot. But remember, you got to put it in parentheses. Which means you're going to have to do 2x plus 1 times 2x plus 1, and then subtract 3 from your answer. Your final answer is 2x squared plus 4x minus 2. We're going to skip C. Again, just because of time purposes. Does it make sense how to plug a function into a function? Yes, no, maybe.
I'm getting.
You'll need to practice, but for the most part, yeah?
I understand a little bit.
Okay. You're not going to have to do composition of functions and domains on your assessment. So I'm not going to, we're going to say skip. Inverses. We got one section left, and I'm going to try to just do the key points of this. Sound like a plan? Cool. There's a few things that must happen in order for it to have an inverse. It must be something called one-to-one. Easiest way to figure out if it is one-to-one. It means it passes your vertical and horizontal line test. It means X cannot repeat and neither can Y. No repeating X's or Y's. This graph looks like this. This is one-to-one. Because I can put a vertical or a horizontal line on that, and none of it will repeat. This is not one-to-one. Because if I put this horizontal line here, it hits twice. For it to be one-to-one, I would have to get rid of half of that graph and only have one part of it. The blue part is one-to-one, but that whole thing is not. 2 root x.
Pay info, Ken, to the office, please.
Looks like that. That is one-to-one. to find an inverse of a function. An inverse undoes something. So the inverse of a square root is squared. The inverse of +1 is -1. The inverse of times 2 is divided by 2. They're kind of like operations that undo one another. Well, these functions, if you take a function and plug it into its inverse, you just get x back. Okay? So this must be true for both. To verify that they are inverses of one another, f composed with g of x must equal g composed with f of x, and they both must equal x. That is one of the biggest things to know, that these functions are inverses of one another. And this is for inverses. So what we just talked about was taking the function f, which is 2x plus 3, 2 stuff plus 3, and inside there, plugging in x minus 3 over 2. And then let's simplify. The 2's cancel. We're left with x minus 3 plus 3, which just gives us x. So far, so good. Everything canceled except for x. Next, we want to see, is that equal to g of f of x? Which means we have stuff minus 3 all over 2. And the stuff that is in that spot is 2x plus 3. The first thing that cancels are the plus and the minus 3. So that's 2x over 2.
Rain Fernandez to the office, please. Rain
Which gives
Fernandez
us
to the
x.
office.
They both equal x, so yes, they are inverses. Now, how the heck do we find an inverse? One, switch x and y. 2, solve to get y equals. So, first step, switch x and y. Second step, get y by itself. Here, we'd add 4 to both sides. So we have x plus 4 equals 3y, but what do we have to do now? Divide everything by 3. So x plus 4 all over 3 equals y. This is the inverse. You can check it by plugging that original function into that, and by plugging this into your original function. We're going to skip 6. But we're not going to skip 7. First step. Switch x and y. I do not change the exponent. All I did was write an x instead of a y and a y instead of an x. I kept the exponents where they were. Okay? Now, how would I get y by itself? Not yet. There's one step first. Add one
Nisha
first.
Cloud to the office, please. Nisha Cloud to the office.
X plus 1 equals y squared. Now, what do I have to do? Square root. That's how I get rid of that exponent of 2. Anytime I take a square root, what must I have? Plus or minus. But this one's a little different because, and I'm going to highlight this in blue, it says that x has to be greater than or equal to 0, which means I only need this positive version here. So my actual answer is the positive square root of x plus 1 equals y. This is going to be a really good one to put on your cheat sheet for your test. I'm just going to say that now.
We have a test on Thursday.
I think so, yeah. At least I'm pretty sure. All right, one last thing, even though it's not within our notes. Make sure you look over the review. The review is spot on with what you're going to see on your test. When it comes to graphs of inverses, again, graphs of inverses, the original is x comma y. The inverse is y comma x. What I mean by that, if I have 1 comma negative 3, 2 comma 5, and so on, the inverse is going to have negative 3 comma 1 and 5 comma 2. You're going to switch the points for x and y, and that is how you graph an inverse. Got it? Okay. We did it. Kinda, sorta, maybe.